last little bit here, we are going to go through a little bit more about electron configuration, talk about order of orbital fill, and also work through an example to show you exactly how this is done. You will have this information in terms of the graphic organizer for you as part of your test. So, how we fill electron configuration orbitals is based on energy. In the beginning, the low energy levels, this makes it easy because they actually fill in order based on the way we've talked about it. So we first fill up the 1s with 2 electrons, and then we move out to the second energy level, to the 2s orbital. When that is full with 2, we then move to 2p and put in 6, and then 3s with 2 more, and then 3p. So that's pretty easy. The challenge becomes after that. If we look at the comparison between the energy of the d orbitals at the third energy level, so 3d versus 4s, we hit a snag. The 4s orbital actually has less energy than our 3d orbital. So after we fill up 3p, we don't actually go ahead and put orbitals into 3d. We first put them into 4s. After the 4s gets filled, and again, that's only 2 electrons, we go and we start to fill the 3d orbitals. And this order of fill follows the diagonal rule. And this graphic actually shows you the diagonal rule. And you will see this as well on your test. The key here is knowing exactly how to work with it. So, the diagonal rule. You start up here, where that dot is, and you actually draw a diagonal line like this. And as you draw it, you go through the 1s orbital. That one gets filled first. Then you come back up here to the top and go down across diagonally through 2s. Then come back up. I go through 2p and then 3s. And then up here, 3p through 4s next. And then back up. 3d, 4p, 5s, and so on until all of the orbitals are filled. So that is how you use this graphic. Now you can also see this in an energy diagram. And that's what you have on the back page of your notes that looks like this. So you can see here we have the energy levels. We have the energy levels here, okay, 1, 2, 3, and 4. And then each energy level splits based on the orbitals. So I would go up this way, 1s, then 2s, then 2p, then 3s, 3p. And you can actually see I hit the line here for 4s before I hit 3d, and so on. There would be more overlap at the top, but we only have 4 energy levels on this particular diagram, and that's okay. So the last little bit we need to do is actually write our electron configurations. So we have, how do we write the actual electron configuration? So we have to talk about, okay, not only do we place electrons in the orbitals, but we also need to write the electron configuration out. All right, when we write an electron configuration, we need 3 different parts. We need the energy level number, and this is for each type of orbital that has an electron. So for s and p, for instance, I would put a number in front of both of those. The orbital type, whether it's s, p, d, or f, and the number of electrons in those orbitals. So we're actually going to do an example of copper, okay, using your graphic organizer. If you look copper up on your periodic table, copper's atomic number is 29. And that number is important because it tells us how many electrons we're actually going to place in our graphic organizer. Now, the first thing we are going to do with our graphic organizer is actually place electrons. And when we place electrons into the graphic organizer, we place them in pairs. In that pair, we have 1 half arrow going up and 1 half arrow going down. This is for something that we call electron spin. We're not going to get into the details of exactly what spin is and why it is important, but I also want to show you how to draw these correctly. All right, so We're going to start down here at the bottom with 1s, so I'm going to put 1 electron in and 2 electrons in. Then I'm going to move up to the next line, which is my 2s, and I put another 3 electrons, 4 electrons. Now when I get to the 2p, you can see here I actually have 3 separate orbitals. Electrons are a little bit like kids. They want their own space. So when I place electrons in, I put 1 in each orbital before I go back and double them up. So that's 9 and 10. Then I go up to the next level, 3s, 11, 12, 3p, 13, 14, 15, 16, 17, 18, now 4s, 19, 20. Now I do the same thing on the d's that I did before, 21, 22, 23, 24, 25, 26, 27, 28, and 29. That's what it would look like on my graphic organizer. But that is not the electron configuration. That is a tool that we are going to use to actually write the electron configuration. When I write the electron configuration, I start down at the bottom. So I start down there with 1s. That gives me my energy level number and my orbital type. The other thing I need is the number of electrons. So to do that, I count the number of half arrows that I have on that line with the 1s. And I write that as a superscript or an exponent, which is 2. Then I move up to the next line, which is 2s, and again it has 2 electrons. Then I go to 2p. It has 6 electrons. And then 3s, which has 2, 3p, which has 6. Now remember, this line here is 4s, so that gets written next with 2 electrons. And then 3d, which has 9. When I ask for the electron configuration, that is what I am asking for. Now you're going to get a lot of practice with this, writing cards for an electron configuration activity. So if you're not comfortable with this at this point, we're going to be working with the cards, and if you're still not comfortable with it, that's the time where you need to come and get some extra help.